Open shortest path first, OSPF, follows this hierarchy design. You see, every area must be connected to area 0. Area 100 is connected, area 200 is connected. If you have more areas, then more, you can also have another connection here, another area, another area, another area, another area. So, area 100, 200, area 300, area 400, area 500, area 600. So theoretically it is said in each area you can have up to 255 networks. In each area you can have 255 networks. Then think about OSPF scalability. It really supports huge network. In each network, 255 network in each area. If I have 10 area, then 2,500 area networks. 2,500 networks. This is just small calculation I'm telling you. You can have even much more than that. What I'm trying to say is OSPF is highly scalable. It is all because of this hierarchy design. You have two tier architecture. One is area 0, another one is non-backbone area. Area 0 is called as backbone area. Why it is called as backbone area? Because every network distribution from one area to another area goes through area 0. If the networks of area 100 needs to reach area 200, even if you have a connection like this, not possible. Why? This won't form neighbor. This is a wire. This end is in area 100. This end is in area 200. If area ID is not matching, they don't form neighbor. They don't form neighbor. When area ID don't match, they don't form neighbor. If they don't form neighbor, they cannot share any routes. So the only possible way is to go through backbone area. Now you may ask how this forms neighbor. Actually, this link, this port is a member of area 0 only. This is also a member of area 0. Only this wire, this is 100. And this is also 100. They form neighbor. They form neighbor here. This also they form neighbor. Now this router where you have area 0 and other area called as ABR. Area Border Router. Only through ABR routes get distributed from one area to area 0. Again, I want to tell you a very big secret of this OSPF. Routes of one area like 100 will be given only to 0. If you will have here another area, let's say area 500, the routes will not be given, even though it is on the same router, the routes will not be given. OSPF is designed to give only to area 0 link. Area 200 networks will only be given to area 0 link. So if I have another area here, area 600, the routes of 200 will go here and then go like this. What exactly I mean is the routes of 200 will be given to 0, which is here. That 0 will give to this 600. So there is no direct conversations. There is no direct distribution of route. It is only through area 0. That is why the area 0 is considered as a backbone area. You see, for our body, we have a backbone. No commands from your brain bypasses backbone. Every single command that brain gives, it goes only through backbone. You want to move your hand, the brain send the command through the backbone. The nerves are connected via the backbone to the hands, so that the hand can move. Everything is controlled by brain, and the brain carries the control commands through the backbone to the rest of the body, except the parts of the head, except the head. All other organs below the neck is controlled only through backbone. So the name backbone is given. Every single update is only through backbone. And area 0 alone, the number 0 is only the number that can be backbone. We cannot use any other number except 0. 0 means OSPF understands that this is a backbone. These are all predefined. You cannot change. As per the standard OSPF means it will use number 0 for backbone. Next, the backbone area is also called as transit area. That's another name given. Transit. Transit area. What is transit? See, if you are going to Kuwait, let's say you don't have a direct flight. You have direct flight, but they are very costly. Assume very costly. So what you do is you took Oman Airlines, sorry, not Oman Airlines, Qatar Airlines. You go to Qatar and then take another connection flight to Kuwait. So now this Oman, what did I say? Qatar. This Qatar. This Qatar is a transit for you. Your original source is maybe Chennai. Your final destination is Kuwait. But in the middle, you have to go through Qatar. Whether you like it or not, you have to go through Qatar because that flight only goes through Qatar. Qatar Airways. You need to change your flight in Qatar. Qatar is not original source or destination. That's a transit. In between. Transit is nothing but in between. Originally, the traffic goes from here. It wants to get delivered to 200. but for that it has to deliver to every router in area 0, only then it can go to 200. That's why area 0 is also called as transit area. Transit area, backbone area, both are same. Now, what is the name given to these areas? These are all not backbone areas. Non-backbone areas. Non-backbone areas. And also it has got another name, regular area. Regular. Regular area means non-backbone. Transit area means backbone. Transit. That is area 0. All other area are regular. Can area 200 be transit? No. Even if I have another area here, area 700, you cannot call 200 as a transit. First of all, this is not allowed. If you want to have it, there is one option called virtual link, which we'll be learning in next level of OSPF, CCNP level. What I'm trying to say here is, even if you have that option of virtual link, you cannot call this as backbone or transit. They're only non-backbone regular areas. Only area 0 can be titled as transit backbone area. Now, this router is called as ABR, area border router. Even this one. These routers are simply called as non-backbone routers. And these are backbone routers. This is fully backbone because it's fully into area 0. It is fully into non-backbone areas. Or internal routers. You can also call it as internal routers. This is internal, this is border. In that way, it is internal. This is backbone router. These are all non-backbone routers. So what is ABR? Area border router. Now to make a router as the ABR, there is no special commands. No special commands. Whenever you put one interface in area 0 and other interface, one or more interface in other area, automatically the router will know that I'm an ABR. I repeat, there is no special command to make a router as a ABR. If a router is configured with area 0 on one port and some other area on the other ports, they are called as area border router, ABR. Right? Area border router. There is no special command. That is what I want to remind you. Don't try to search some command. You will not get. He said ABR. Now, how it is ABR? What makes the router to be ABR? Don't think like that. So what makes is this one? At least one port will be in area 0. Then it is ABR, area border router. Okay. Now, On the other day, when we configured like this. In this router, let's say this is router 2, and we said in the global configuration mode, network. Same like what you used to have in OSPF, sorry, EIGRP and RIP. Same like that network. But the difference is, after you put that network, you need to provide, it is mandatory, you have to provide wildcard mask. Followed by, you must provide area ID. This is the syntax. This is how I configured on the other day. Let me explain this. Let's say here, I have 10.12.0.2. And in here, 10.10.0.2. Now, I want this to be in which area? Area 0. This one? How can I say that? Oh, sorry, I forgot to put one more line of command. Here it is. Router OSPF process ID. Okay, now this will take me to OSPF mode, router mode. Be like this. So router OSPF 1 network. You see, if I simply put 10.0.0.0 and area 0, what will happen? This also will run in area 0. No, that's not our aim. Our aim is this network 10.12 should run in area 0. So what we do is we put 10.12 here. We put 10.12.0.0 and we say these two must match on an interface. Only then that interface will be a member of area 0. So for that, we put this number 0.0. What does that mean? It means that the first and the second octet must match. And then the other two octets, we don't care. That is why we put 255. 255 means what? We don't care. Or 0 means what? Match. So I'm putting only 0 for 2 octets. So it will check this 2 octet and here only it matches. So this port will be member of area 0. And for the other one, what I'll do like this. Network 10.10.0.0 0.0.255.255 area 100. That's it. So it will check the interface whose IP address is 10.10. Only that interface will be a member of area 100. You understand now why wildcard mask? Without wildcard mask, this is not possible. So we need to use wildcard mask, and it is mandate to configure OSPF. It is mandate. But I'm also going to teach you another method, better, easy method, latest method. This is classical method. In the next class, I will teach you another method, but first you have to learn this. So I don't want to go rush to that method. You will forget this one because that is easy. But this is also important. So you learn this one today. We have wildcard mask. You use wildcard mask followed by area ID. This is the syntax. All right. Now, I want you to do one lab with very clear, proper knowledge, and come tomorrow so that we can have one more day of CCNA OSPF along with everyone, and then we'll finish this. Okay, I'll stop here today.